Hello students, how are you all? I hope everyone fine. So in last class we started to learn a new chapter called mathematical induction. Maybe you remember, and also along with the theory I explained two problems, so it's continuation of that. Remember, including the previous two problems, these are also the very important 5-mark question. Remember that. Maybe I told in the last video that this chapter is exclusively for 5 marks, not less than that. Okay, yeah. So one more question for today. Okay, in mathematical induction is 1 square plus 2 square plus 3 square so on up to n square equal to n into n plus 1 into 2n plus 1 by 6. This we have to prove by mathematical induction. Maybe you remember what are the different procedures in mathematical induction. I'll recall that concept through this particular problem. Observe carefully. So proof is as follows. Take the given statement as p of n. Okay, take the given statement as p of n. It is enough if you write first two statement terms and the last term and the right hand side. Okay, write down the given sentence again in exam, because you will not write the question in exam, okay, answer paper. So you have to write the given statement and write it as a p of n. Okay, fine. Now we have to verify this result is true for 1 or not. So put n is equal to 1 both in LHS and RHS. So what is LHS? 1 square, which is equal to 1. So what is RHS? RHS is this right hand side, that is 1 into 2 into 3 divided by 6. Check. Yeah, it is also equal to 1. So therefore what is the conclusion? P of 1 is true, because both LHS and RHS are equal to 1. This is the first step. Take the given statement and verify result for n is equal to 1. If it is true for n is equal to 1, then assume, okay, that p of k is true. Maybe you remember why I am taking like this. Okay, p of k is true. That is, write down the p of k. Replace n in terms of k. That's it. Again, first two term and the last term is enough. Okay, in right hand side replace all n by k. Okay, so you are going to name this as a equation 1. Okay, you name this as a equation 1. Maybe you remember what we should do next. Yeah, using this assumption you have to prove that it is true for p of k plus 1 also. Okay, so next work is to prove, p of k implies p of k plus 1. So this we have to prove. To prove p of k implies p of k plus 1, what it means? You have to assume that result p of k is true, and you have to prove using that assumption that p of k plus 1 is also true. Yes, so write p of k plus 1 once. Remember, don't use this, you have to get this answer. Again, first term and last term is enough. What is the next term of k square? Yeah, k plus 1 whole square. So right hand side anagate k plus 1, k plus 2. Observe madi, illi k plus 1 anna replace madbek. 2k plus 2 plus 1 andre 2k, yeah, plus 3 divided by 6. Please remember that this you have to get, don't use anywhere, because bracket you should get this, you should not use it. Okay, yeah. So now compare 1 and this. Compare yeah, what is missing? What is missing in the 1? K plus 1 whole square is missing. So add k plus 1 whole square to both side of 1, and pele you should add to 1, not to this. This is the answer that you should get it at the end. So you should use this. So add k plus 1 whole square to both side of 1. So what is left hand side? 1 square, 2 square, so on up to k square already. So in add martidave k plus 1 whole square we are adding. Remember, you are adding the right hand side of 1. Okay, please remember, because usually this expression ill add martide, okay, simplify madre, you will not get the answer, so be careful. Yes, so you should add with 1. So k into k plus 1 into 2k plus 1 divided by 6 plus k plus 1 whole square. So the last work is to simplify this expression. Okay, so left hand side of the problem illa already now compare madre, yeah, it is nothing but the required left hand side. So only you have to simplify this expression, to match with this above expression. Okay, simplification andrenu, taking the common term outside, taking LCM and rearrange. Okay, which is the common here? K plus 1 is common, alva. Take k plus 1 outside. In barate k into 2k plus 1, k into 2k plus 1 divided by 6 plus k plus 1. Take the common term outside. Now take, okay, LCM. K plus 1 will remain as it is. LCM ತಗೊಂಡ್ರೆ ಏನಾಗುತ್ತೆ 2k square plus k plus 6k plus 6 divided by 6. LCM ಗೊತ್ತಿದೆ ಅಲ್ವಾ? Very good. So this is nothing but k plus 1 into, okay, you can write this as a 2k square plus 7k plus 6 divided by 6. Factorization in second order quadratic equation. So if you factorize, this is your work, okay, directly you can write because that answer is there, but you try it once, okay, you can write the factors directly like this is nothing but k plus 2 into 2k plus 3, you can check 2k square, 3k, 4k, 7k, 2 plus 3, 6, it match, okay, divided by 6. Now compare the left hand side, already we have, compare the right hand side. Yeah, even you got that. So if it is true, then what we should write? Yeah, which is p of k plus 1. So therefore p of n is true for all n belongs to n by mathematical induction. ಈ conclusion ಬರೀಲೇಬೇಕು ನೆನಪಲ್ಲಿ. If you not write this if you not write this conclusion in exam, you may lose 1 mark and you will lose 1 mark, remember that, okay. ಖಾಲಿ conclusion ಬರೆದ್ರೆ marks ಸಿಕ್ಕಲ್ಲ, but if you not write at the end, you will lose 1 mark, okay. So ಅರ್ಥ ಆಯ್ತಾ? ಇದೊಂದು important question ನೆನಪಲ್ಲಿ, very important question, okay. It will be asked in final exam for 5 marks. So one of these questions definitely you will get in exam for 5 marks. So ಅರ್ಥ ಆಯ್ತಾ? First ಅದೇನಿತ್ತು 1 plus 2 plus 3 so on up to n, next 1 cube plus 2 cube plus 3 cube so on up to n cube, and third one is 1 square plus 2 square plus 3 square so on up to n square. Actually you are going to remember the first 3 answer, okay, as a formula in one more chapter, remember that, okay. This formula is required, okay, this problem is required as a formula in one chapter, okay, remember that, very useful. So next question, 1 plus 3 square, so 3 cube and so on up to 3 power n minus 1 is equal to 3 power n minus 1 divided by 2, okay. Yeah, proof, the procedure will be same for all problems, okay. You take any problem in mathematical induction, the procedure will be same. So take the given statement as p of n, okay. What is p of n? Writing same thing again. Okay, put n is equal to 1 first in LHS, the first term which is 1, and RHS on the E term 3 power 1 minus 1 by 2, even this is also 1. So what is the conclusion we can write? Yes, p of 1 is true. So one step is over. You proved or you verified the given question is right for n is equal to 1. Fine. Next in madbeko, yes, you're right. Assume p of k is true. Assume p of k is true. What do you mean by that? Yeah, p of k is equal to 1 plus 3 square so on up to 3 power k minus 1 is equal to 3 power k minus 1 by 2 is true, okay. This you're going to use to get the whatever required, okay. Yeah, now what is required? Required is, you know, p of k implies p of k plus 1. So this we have to get it. So what is p of k plus 1? Yeah, it is 1 plus 3 so on up to 3 power k minus 1 plus next term of that 3 power k plus 1 minus 1 by 2. K ide adanella replace it by k plus 1, so you will get like this. So remember this you have to get, don't use anywhere. Yes, now compare 1 and this expression. Here to compare madaga 3 power k minus tanka ide, so which is missing? 3 power k is missing, so what we should do? Add 3 power k to both side of 1. Add 3 power k to both side of 1. Very good. So left hand side ಏನು ಕಷ್ಟ ಇಲ್ಲದೆ ಬಂದ್ಬಿಡತ್ತೆ, okay ಅಲ್ವಾ. Left hand side easy ಇದೆ 3 power k. Right hand side important always to get, okay, the required answer. ಎಲ್ಲಿ add ಮಾಡಬೇಕು ಇದಕ್ಕೆಲ್ಲ, remember you should add to 1 3 power k minus 1 by 2 plus 3 power k. ನೆನಪಿಲ್ಲಿ you are not adding to the required answer, okay. So this is also equal to 3 power k by 2 ಬರಿಬೋದು, ಇದು 1 by 2 ಬರಿಬೋದು, next 3 power k. So ಈ ಎರಡು ಟರ್ಮ್ ಇಂದ ಏನು ಕಾಮನ್ ತೆಗಿಬೋದು? Yes, right, 3 power k you can take it outside. So you'll get 1 by 2 plus 1, 1 by 2 plus 1 minus 1 by 2, that is 3 power k, 3 by 2 minus 1 by 2, that is 3 power 1 into 3 power k ಏನಾಗುತ್ತೆ? 3 power k plus 1 divided by 2 minus 1 by 2, that is 3 power, I can write like this, right? No? Now ಈ ಆನ್ಸರ್ ಅನ್ನ ಈ ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಅನ್ನು ಕಂಪೇರ್ ಮಾಡಿ, whether it will match. Yeah, 3 power k plus 1 minus 1, okay, minus 1 divided by 2, it will match with the required expression, therefore which is p of k plus 1. Therefore according to the mathematical principle of mathematical induction, we can write p of n is true for all n belongs to n by mathematical induction. Done. See, very easily you can answer, okay, these questions for 5 marks without any difficulty. Simplification ಏನು ಇಲ್ಲ ಜಾಸ್ತಿ, so in the questions ಬಂದ್ರೆ miss ಮಾಡಬೇಡಿ. Okay, so I hope fourth question is also you understood. Any doubt ಇದೆಯಾ? Okay, fine. Yeah, so we'll continue the same procedure. I wrote one more question, which is fifth one, 1 into 2 into 1 into 2 plus 2 into 3 plus 3 into 4, so on up to n into n plus 1 equal to n into n plus 1 n plus 2 divided by 3. Yeah, next question. Okay, it's look like product, but it sorry, dot, it is not 1.2, it is not 2.3, it is 1 into 2, it is 2 into 3, 3 into 4. Remember that it's not point, it's a product. Yeah, the same procedure, take the given statement as a p of n, 1 into 2 plus 2 into 3, 2 into, remember not point, so on up to n into n plus 1 equal to n into n plus 1 n plus 2 divided by 3. Take the given statement as p of n. Fine? Yes. Now verification. Put n is equal to 1. LHS, the first term. What is the first term? 1 into 2. 1 into 2 is 2. Now substitute same number in RHS. What is RHS? E expression substitute ಮಾಡಬೇಕು. 1 2 3 divided by 3. 3 3 cancel. So what is remaining? Yeah, 2. So what is the conclusion? Right? LHS 2, RHS is 2. Therefore, P of 1 is true. Therefore, P of 1 is true. Artha aita? Very good. So after verifying the result is true for n is equal to 1, then you have to prove the result for n is, you have to prove result is true for all n. So for that you should, assume P of k is true. Assume P of k is true. That is, what is P of k? 1 into 2, 2 into 3, right? So iದೇ ತರ ಕಂಟಿನ್ಯೂ ಮಾಡಿದ್ರೆ ಏನು ಬರುತ್ತೆ? k into k plus 1 equal to, alva, k into k plus 1 is equal to k into k plus 1 into k plus 2 divided by 3. So let it be equation 1. So this you have to assume that true, or this you have to use to complete this work. Yeah, so what is the next step? Yes, we have to prove that P of k implies P of k plus 1. You have to prove that P of k implies P of k plus 1. So write down what is P of k plus 1. P of k plus 1, 1 into 2, 2 into 3, so on up to, ee term bande barata as it is, plus next term of k is k plus 1. Next term of k plus 1, k plus 2. Idu left hand side aitu. So right hand side ಇಲ್ಲಿ ಬರುತ್ತೆ ನೋಡಿ. Next term of k, k plus 1. Next term of k plus 1, k plus 2. The next term of k plus 2, k plus 3 divided by 3. ಇದು prove ಮಾಡಬೇಕು ನೆನಪಿಲ್ಲ. Don't use this, you have to prove it. ಹೇಗೆ prove ಮಾಡೋದು? When you compare this and 1, which is missing, k plus 1 into k plus 2 is missing. So that term we should add on both sides. Add k plus 1 into k plus 2 to both side of 1. So left hand side without any difficulty problem will be solved. Okay, k plus 1 into k plus 2 equal to, so left hand solved. Now right hand side 1 ಗೆ add ಮಾಡಬೇಕು, ನೆನಪಲ್ಲಿ careful ಆಗಿರಿ. Divided by 3 plus k plus 1 into k plus 3, sorry, k plus 2. Yeah, once you add, the left hand side is already done. Okay, nothing to worry about it. Now right hand side you have to simplify. I'll write it from here. Here compare ಮಾಡಿದಾಗ ಯಾವುದು common term? K plus 1 is K plus 2. Both are common in both term. So take it outside. Always follow the procedure that first always you take the common term, next always you take the LCM. Remember that. So take this outside, you will get K by 3 plus 1. Alva? Simplify further. You know, K plus 1, K plus 2. Alva? Take LCM here. In Bharat x plus 3 by 3. Now compare this and this, whether it will match? Definitely. So these two will match. So this is, you know, which is P of K plus 1. Therefore, P of n is true, okay, for all n belongs to n by mathematical induction. ಅರ್ಥ ಆಯ್ತಾ? ಇದು ಒಂದು ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್ ನೆನಪಲ್ಲಿ, ಎ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್ ಫಾರ್ 5 ಮಾರ್ಕ್ಸ್. ಓಕೆ, ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಕೇಳಿರಿದೆ ಪರ್ಟಿಕ್ಯುಲರ್ ಕ್ವಶನ್. ಪ್ಯಾಟರ್ನ್ ಮೋಸ್ಟ್ಲಿ ಅರ್ಥ ಆಗಿರಬೇಕು. ಓಕೆ, ದ ಪ್ರೊಸೀಜರ್, ದ ಅಲ್ಗೋರಿಥಮ್. The problem will ಕಷ್ಟ ಇರೋ part right hand side simplification. Whole problem will be difficult depending on the right hand side simplification. Suppose right hand side simplification is easy, this procedure is very simple. The problem will be very, very simple, because up to here up to writing this term is same as, okay, for all such problems. It is same for all such problems. You know, around 5 to 10 problems is there. So all problem procedure same. Only the right hand side simplification is different. I hope you understood. So next question, the fifth question. See, it's almost like the previous one. In previous problem you got 1 into 2, 2 into 3, 3 into 4 and so on. In one extra, you know, 1 into 2 into 3. The three sequences are combined. Last the error sequence more sequence there. But try to understand, this is not decimal point, it's a product. Okay, 1 into 2 into 3, and don't even multiply also. Don't write like this 6 plus 24 plus and so on. Then you cannot solve this. You should keep everything as it is, same. Okay, don't change anything in the question. Yes, the procedure you know, take the given problem as P of n. What is P of n? 1 into 2 into 3, 2 into 3 into 4, so on up to n into n plus 1, n plus 2 is equal to n into n plus 1, n plus 2, n plus 3 divided by 4. Okay, very good. Now verify the result for n is equal to 1. LHS, you know, the first term, always LHS is the first term. 1 into 2 into 3 ಅಂದ್ರೆ 6. ಇದೇ ನಂಬರ್ ಅನ್ನು RHS ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ RHS ಅನ್ನು ಈ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. ಹಾ, ಹೇಳಿ. 1 into 2 into 3 into 4 divided by 4. 4 cancel. Yeah, even this is also 1 into 2 into 3 equal to 6. So what is the conclusion? RHS is 6, LHS is also 6. So P of 1 is 2. Therefore P of 1 is true. Very good. Now assume that P of K is also true. Okay, using this verification you can assume that it is true for K. Yeah, what is P of K? 1 into 2 into 3, 2 into 3 into 4, so on up to K into K plus 1 into K plus 2 equal to K into K plus 1, K plus 2, K plus 3 whole divided by 4. And you name this as the equation 1. Okay, remember you have to use this. Okay, this is our tool to get, okay, solution for this, to get the proof of this particular problem. So then use ಮಾಡಬೇಕಾಗುತ್ತೆ. So what next? Yes, we have to prove that P of K plus 1 is also true using the assumption that P of K is true. So let me write once P of K plus 1. 1 into 2 into 3, 2 into 3 into 4, so on up to K into K plus 1 into K plus 2. ಇಷ್ಟೇ ಆಗಲ್ಲ, ಇದು P of K ಆಯ್ತು. So what is P of K plus 1? ಇದರ next term ಏನು? 1 ಇದದು 2 ಆಗುತ್ತೆ, 2 ಇದದು 3 ಆಗುತ್ತೆ, 3 ಇದದು 4 ಆಗುತ್ತೆ. So K ಇದದು, yes, K plus 1, K plus 1 become K plus 2, K plus 2 become K plus 3. Same procedure you should follow in the right hand side. ಏನದು? K plus 1, K plus 2, K plus 3, K plus 4 whole divided by 4. Remember this you have to get. Okay, you have to get this expression. You should not use it. You should get this expression. Okay, so getting this expression from this is not difficult. Remember, it looks like very lengthy but simple. So next, compare one and the expression which you should get and decide which term you have to add. Idere compare madidre yavadu missing ide. Okay, one alli il tanaka matra ide. So this is missing alva. This is missing, so this particular term you should add. So add the next term which is not there. Yeah, k plus 1, k plus 2, k plus 3 to both side. Add k plus 1, k plus 2 and k plus 3 to both side of which one? 1. Okay, so up to k into k plus 1 into k plus 2 you can see in 1. Since we are adding this, so one more term will be added to left hand side. Adeno k plus 1, k plus 2 and k plus 3. Compare ಮಾಡಿ. See, when you compare the left hand side of the one after adding and this expression one and the same, so left hand side problem solved. Now we have to add this to right hand side. What is right hand side? Idan use ಮಾಡಿ careful ಆಗಿ. K into k plus 1 into k plus 2 into k plus 3 divided by 4 and you are adding this term, that is k plus 1, okay, k plus 2 and k plus 3 to both sides. So when you add, you know the procedure. You should take the common term outside. Yavudalli common term? K plus 1 is common, k plus 2 is common, k plus 3 is also common. So take that outside. K plus 1, k plus 2 and k plus 3 outside. So you will get k by 4 plus 1. Take LCM. K plus 1, k plus 2, k plus 3, k plus 4 by 4. Now compare this. K plus 1 is k plus 2 is k plus 3 is k plus 4 is divided by 4 is. So okay, it will match with the expression p of k plus 1. Therefore p of n is true for all n belongs to n by mathematical induction. Understood? Very good. Thank you.